All right, we are starting chapter 2 today. So we're in 2.1 to 2.2 in your chapter 2 book. And today we're really going to be starting the conversation about solving equations. We're solving for a variable. This is still some pre-algebra stuff, so you've already seen this before. We might go a little more in depth. We might go a little faster. So before we even start, one key thing that I want to bring to your attention is that we now see the directions solving. Okay, so up until this point, we've only ever seen the words simplify and evaluate. Okay, both of those only happen when we have expressions. Okay, so now let's talk about the difference between an expression and an equation. Okay, an expression has no equal sign. An equation has an equal sign. Okay, so we see equal signs now. Okay, that's a key difference in the world algebra. All right, when we solve these, we like to think about their opposites. Okay, opposite operations. So for addition, its opposite is subtraction, or its inverse, or its reverse. Right? They go back and forth. They undo each other. Division, match, is multiplication. Okay, and those undo each other. They're inverses or reverses of each other. Okay. All right, so when we solve this, I know this seems simple, but I want us to get in the habit of being neat and keeping everything organized, because as we go, good habits are going to lead to less mistakes as our problems get more and more complicated. So I always tell students to draw a line straight down from their equal sign, and we call this the mirror line, and you'll see why in a minute. But the first step, we should always just draw a line down from the equal sign. Now, when we solve equations, the goal is to get the variable by itself. Okay, that's the goal. Goal, get variable by itself. Okay? So our goal is to get x by itself on this side of the equal sign. So in other words, everything else that's over there, we want to move to the other side. Well, in order to move it, we use our inverse operations. So I see a plus sign. The inverse of addition is subtraction. So I'm going to subtract 30. Notice how I have it lined up. Okay, right underneath, the signs match up, the numbers match up. Now, the reason I called this the mirror line was because whatever I do to this side of my mirror line, I have to do the other side. These sides should reflect each other. Okay, so I subtracted 13. I subtracted 13. My 13s over here go away, and I'm just left with my x equals 27 minus 13 gives me 14. I ask myself, okay, is my variable by itself? The answer is yes, so I'm done. Okay, go ahead and try number 2. All right, for number 2, you should have subtracted 2 from both sides because we had to do the inverse. This resulted in my 2's going away. My y comes down, and I get negative 6 minus 2 gives me negative 8. If you got 4 or negative 4, okay, 4 or negative 4, make sure you be careful here of negative 6 minus 2, okay, negative 6 minus 2. Use your calculator. If you type that in your calculator, it's really 6 plus 2, but we're dealing with negatives, so it's a negative. All right, here we have the next one. Remember, draw your mirror line. Now I look at my problem, I see that I have subtraction. So the inverse of that is now addition. So now I'm adding 8 to both sides, because remember, whatever I do to one side, I have to do to the other. So now I'm adding 8, because that's the inverse. That results in my 8's going away. I have my m left over, and then negative 14 plus 8 gives me negative 5. Go ahead and try number 4. Oh, actually, pause. Don't try number 4. Number 4, don't panic. we see these fractions and we start to lose our marbles, okay? Don't panic. What do you notice about these fractions? They've got the same denominator. If they've got the same denominator, I'm able to add or subtract them. I don't have to do anything to them, okay? So don't overthink it. Let's just treat these fractions like any other number, okay? Draw my mirror line. I look on this side. I notice that I see a minus. So I know the inverse is addition. 3 over 2. Add 3 over 2 on this side. If it's difficult to add because it's going up and down, feel free to write it again over here. My brain, it works a little easier. When we add fractions, my denominator stays the same when we add or subtract. So when this is a plus or minus, the denominator stays the same. So it stays at 2 across the board. Then we just add the numerators. 1 plus 3, I get 4, which simplifies to 2. Okay? So y equals 2. Okay? Because my y came down. All right. Let's look at our next page. Now we're going to be solving equations. And there's still one step. Okay? We're going to use division now. So same rule applies. Start with your mirror line. Now I have 15 times x. When they're up against each other, I know this is multiplication. So I have times x. The inverse of multiplication is division. So I'm going to divide both sides by 15. Okay, so I divided this side by 15. I have to reflect that, do the same thing across my mirror line. Okay? When I divide 15 divided by 15, they go away, right? They technically become a 1x, right? 15 divided by 15 is a 1, which simplifies to a 1x, which we know is just x. Okay? So that's how that works. It cancels each other out. On the other side, just use your calculator, okay? But in your calculator, do not fall for the trick, okay? We need to do 10 divided by 15. A lot of kids will see that 15 is bigger, and they'll automatically just type 15 divided by 10. That is not what this problem is. This is 10 divided by 15. So we have to, order matters here. We have to do 10 first. 10 divided by 15, you type that in, you would get 0.6. Repeating. If you hit math, enter, you'll get our fraction version, if you prefer that, of 2/3. All right, try number 6. Okay, for number 6, I draw my mirror line. I have 4 times x. So my goal here is going to be to divide both sides by 4. So I have x equals 6.4 divided by 4 gives me 1.6. All right, moving right along. Here's our next one. It looks like a fraction. It looks like I have x over 4 equals -9, which I do technically. But just remember, that fraction bar is really a division sign, okay? So fraction bar, really division. My variable is up top, okay? So my variable is up top. So my goal then would be to move the 4. I want to get rid of the 4 in the denominator. I want to move it over here. Well, if you think about it, it might help to rewrite it. This is the same thing as this is the same thing as x divided by 4 equals -9. Means the same thing. Okay, well, in this new problem that I wrote, I feel like you guys would be able to recognize this. When I see division here, I know that I need to multiply by 4. So I multiply both sides by 4. Those go away. I get x equals -36. Okay? Same applies here. I multiplied by 4 over here. So I'm just going to multiply by 4 over here. Another way that this works, guys, is if you just look at the problem, whatever you have in the denominator, just multiply by it on both sides. Okay, so whatever number's down here, what you multiply by. When we multiply, my denominators go away. Both 4's go away, and I'll show you why that's important in a minute. So I'm left with x, and I have -9 times 4, which gives me -36. Look, the same answer. Okay, now the reason I emphasize that both 4's going away is because oftentimes I'll see students who they will tack on a 4 out here, okay? Because when it comes time to simplify, they multiply both sides by 4, but then they only cross this one off, so they're just left with this 4x. Remember, those 4's cancel each other out, which means they're both gone, which means this 4 is not here. I'm left with just my x. All right, go ahead, try number 8. All right, for number 8, here's my mirror line. I'm dividing by 3, so I'm going to multiply both sides by 3. When I multiply by 3, my 3's cancel. Both 3's cancel. So I'm left with r equals, and then 19 times 3 gives me 57. Very nice. All right. The only other time we'll really see fractions, we'll see fractions 2 other ways today. Okay, we've already seen the way up here where we have a number in the denominator, we're dividing. This way, notice my fraction is right out front. In other words, my fraction is my coefficient here. When my fraction is my coefficient, or it's the number out front, we get rid of it. Okay, we could do 4 divided by 5. We see it's multiplying, so we could do divided by 4/5. Divided by 4/5. Okay? We could do that, for sure. However, there's a slightly easier way. And all it is when I see a fraction out front like this, I'm going to multiply. Multiply. Even though I already see multiplication, I'm going to multiply by this coefficient's reciprocal. Okay? So, for example, reciprocal is when we flip it. So my 5 is now going to be on top over 4. I need to multiply both sides. Okay, so what happens here? Well, the 5's are diagonal from each other, so they cancel. And they cancel. So I'm left with a 1m, or technically an m. Okay? On the other side, you could either type this into your calculator by doing 28 divided by, times 5 divided by 4. Just make sure you put parentheses around that fraction or your calculator will do it wrong. Or you could do 28 times 5, which gives you 140, and then divide by 4. Okay? Either way, you're going to end up with the answer of 35. Okay, so let's try it now in a real-world situation. So we have an online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? So anytime we have a word problem, let's start by defining our variable, okay? So it says how many months can you purchase with a gift certificate? Most often than not, the variable can be found in that question. Okay, so what am I asking you to find? I'm asking you to find the number of months. So let's let m equal number of months. Okay, from here, well, we're ready now to write our equation. So this is an online, blah, blah, blah. You have a gift certificate for $30. So you have a total of $30 to spend. That total is always what our equation equals, okay? We have this much in our pocket. The plan you select costs $5 per month. So for every month, you're paying $5, okay? Therefore, we would say we're doing 5 times M to tell you how much money you have spent on this rental plan. Okay, from here, we're ready to solve. So I bring my mirror line down. I see that it's 5 times n, so I'm going to divide by 5. Divide by 5. I have m equals 6. Now, good mathematicians never just leave their numbers floating around for no one to interpret. Okay, let's write a sentence here. It says, you can purchase 6 months with the gift certificate. Okay. All right, last page. We are almost there. All right, so now we're going to do 2 steps. Okay, when we solve 2 steps equations, we're going to go in reverse order of operations. So what do we mean by that? Well, before we had PEMDAS. Okay, that was the order of operations. The reverse of that would be exactly what it sounds like. We would do the opposite, so we would go this way. So I'd start with subtraction and addition. And then I'd look at multiplication and division. And then I would look for exponents. And lastly, I would look for parentheses. Okay? Another way to think about it is if you imagine like practicing like archery, for example. Let's say you're shooting a bow and arrow. You're trying to hit a target, right? So if I use this for example, the target is whatever term has my variable in it. Okay, so the target has whatever term my variable is in. Okay, so there's my 2x. That's my term that has the variable. When you're practicing bow and arrow, that's your target, right? That's the goal. But you're never going to hit the goal right away. As you practice, you'll get closer and closer. Okay, so the first shot might get you to here. Okay, the first shot might hit +3. You're going to work your way towards the target. You're trying to get rid of everything outside the target, and then you'll deal with the target at the end. Okay, so let's just practice that over here. So it says, what is the solution of 2x plus 3 equals 17? Okay, well first let's give ourselves some room. Okay, all right, here's my mirror line. That stays the same. Now my target, there's my variable, and the letter, its coefficient, okay? I'm going to take care of whatever's on the outside of that target first. So outside of that target is a +3. I'm going to deal with that by doing -3 to both sides. So I have 2x equals. Okay, now we have to ask ourselves a question again. Is my variable by itself? The answer is no, which means I'm not totally done. What's still with it? A 2. The 2 is attached by multiplication. So the inverse is division. So I'm going to divide both sides by 2. So I'm left with x equals 6. Now the nice thing about these on your test is you'll be able to check your answers. Okay, you'll be able to check your answers. How do you check your answers? Well, we're going to take our answer that we just found, and we're going to go plug it in for x and just see what happens. Okay, so here's my equation again. I have 2 times x plus 3 equals 15. All I'm going to do is replace the x with 6. Okay, so I just substitute in. Now let's simplify. 2 times 6 gives me 12, plus 3 gives me 15. Oh, that works. Okay, that works. All right, let's try this one. What is the solution of 5 equals t divided by 2 minus 3? Okay, so first off, identify your target. Where is my variable and its term? Right there. Yes, the divided by 2 counts as being in a term, right? It's not separated from the t by plus or minus. Okay, so now we're ready to solve. Bring my mirror line down. I'm going to do whatever's on the outside of my target first. So I'm going to add 3. I'm going to get an 8 equals t over 2. My 3's go away. Okay, now from here, I'm dividing by 2, or I have a 2 in my denominator. Remember, in order to get rid of that, we are going to multiply by 2. We're going to multiply both sides by 2, do its inverse. Okay, so now I have t equals 16. All right. This is our last word problem of the day. It says you are making a bulletin board to advertise community service opportunities in your town. Okay, so now let's look at this one last word problem. It says you are making a bulletin board to advertise community service opportunities in your town. You plan to use a half sheet of paper for construction paper for each ad. You need 5 sheets of construction paper for a title banner. You have 18 sheets of construction paper. How many ads can you make? Okay, so first let's just talk about this equation. All right, so this first part. 1/2. The 1/2 is coming from where in my problem? Yeah, good. It comes from a half sheet, right? I'm using half a sheet for each ad. Okay, where does the 5 come from then, the plus 5? Well, it comes from the fact that you need 5 sheets of construction paper for a title banner, which makes sense, okay? All right, so now let's simplify. All right, so we draw our mirror line. I do what's on the outside of the target first. Remember, the target is whatever has the variable in it. Okay, so now I'm going to do the inverse. -5, -5. 1/2 A equals 13. Now my fraction is out front, so I need to multiply by the reciprocal. And I'm left with A equals 26 ads. Or if we think about this in terms of a sentence, you can make 26 ads. Perfect. All right, on to the back. Here we go. All right, so try this next one. It's very similar to the one we just did. All right, so this one, your equation should have been 1/4 A plus 4 equals 18. Okay, the 1/4 coming from the fact that we have 1/4 of each sheet of paper. Okay, so I have 1/4 of each sheet of paper. Now I'm going to simplify. So I draw my mirror line. Here's my bullseye. Here's my target. I'm going to do whatever's on the outside of that first. So I'm subtracting 4. I have 1/4 A equals 14. Okay. From there, I'm not done yet. My variable is not by itself. I have 1/4 times A. I'm going to simplify this by multiplying both sides by the reciprocal. So I have A equals 56 ads. Okay. And again, you would write that in terms of a sentence. All right, last part we're going to do here is the last way we might see a fraction. And that's in the case that we have two terms in the numerator. Okay, so I have two things separated by a plus or minus in the numerator. Well, first of all, let's just get it out of the way. This thing looks ugly. It looks scary. I don't even know where to start. Not a fan. Let's just get rid of the denominator. I think I would feel so much better without it there. In order to get rid of the 3, remember, this is a division. I would do multiplication. I would do times 3 to both sides. Remember, when you do times 3 over here, these both cancel out, not just one. Okay? So now I have x minus 7 equals negative 12 times 3, which equals negative 36. Then we add 7 to both sides, and I have x equals negative 29. All right, go ahead, try this next one. All right, so for this one, just copy it down again. We want to get rid of our denominator, so I'm going to multiply both sides by 4. Okay, when I multiply by 4, these 4s cancel out. So I'm just left with 24 equals x minus 2. Then in order to simplify, I'm trying to get x by itself, remember. I'm going to add 2, x equals 26. And that is your notes.